Hi guys, we should make a start. Can everyone hear me first of all? Coolio.
I can hear it.
Excellent. Hey John, how you going? Once again, we're in for an awesome treat. My name's Russell Shepherd from Evolution and EV Up. For those who don't know me or Evolution, we're EV charger and conversion and servicing specialists based out of Melbourne, but obviously nationwide. We obviously service the charging and EV market across Australia and New Zealand, actually. We've obviously yeah, absolutely all good in New Zealand. And obviously we've got Steve Durkin, founder of Safescape, here as well, and he'll be talking us through the awesome product that is the Bortana. What I'll do first of all, we'll go through a bit of housekeeping. So first of all, we've got around I think around 50-60 people on the line, which is great. Obviously it's not possible for everyone to talk all at the same time because that would be an absolute nightmare. However, you can obviously chat amongst yourselves and with us as well via the chat button, but also more constructively, it's possible to open the question and answer box. And what we'll do is we'll go through those. Feel free to ask those questions as we go through the presentation, and we'll make sure we answer those as much as we can through the as we go through the pack. I'll interject and ask those questions on your behalf, obviously, and at the same time, if we don't cover anything off, we'll go through all at the end as well. There's plenty of opportunity, and obviously questions make us the prezzo in our case, obviously. So like I say, you're into a real treat. The other thing is the presentation is being recorded, and we'll be posting it to our YouTube channel tomorrow morning, and a link will be provided through all the usual means and all that kind of stuff as well. So looking forward to this as long as everyone else does as well. The other thing is that let's go on the next slide, shall we? Actually, I think it's time to hand over to you, Steve. So look, I guess the first thing is that I guess across Australia and New Zealand, there's always talk about, you know, when is a ute coming, and people are obviously waiting for the Cybertruck. But the reality is that the ute is already here, the electric ute, that is, in the shape of the Bortana. And yeah, I think the best thing to do is hand over to you, Steve. I'll stop presenting, and then we'll hand over to you, and we'll get it going.
Oh yeah, thanks, Russ. Can you hear me all right?
Yeah, I can. I just need to get out of this. Hang a second. Okay. Okay, right, so all yours.
I'll share my screen. This one. Okay, that should be working.
It is indeed, yeah.
Okay. So Safescape designs, manufactures, supplies and services safety products to the mining industry. To date, we've supplied more than 120 mines across 20 plus countries. And when developing a new product, this product that we work on has to improve safety and or health outcomes in a mining operation that it's designed for, while at the same time increasing efficiency or reducing waste, leading to a reduction in overall cost for the mining operation. Several of our products are unique inventions and have patents spanning the globe. And typically our products are made from plastic, and they benefit significantly from a reduction in exposure to corrosion compared to alternative options. Make a bit more sense later on. So it might seem like a strange progression from manufacturer of plastic safety products to electric vehicle OEM. But at the core, we're delivering the same thing that we've been delivering for 10 years. Safety and health improvements that reduce waste, inefficiency, and drive reduced costs. So an underground mine is essentially a network of interconnected tunnels, often tens or hundreds of kilometres of them, which access areas of rock where concentrations of economically important minerals exist. By creating these tunnels to access the rock that contains these minerals, which we call ore, we're then able to extract them by various means. First breaking the rock and then loading it onto trucks and trucking it out through the tunnels to the surface where we can extract the minerals that go into making our EV batteries, motors, wheels, practically everything you see around and in front of you that is not food. Of course, some mines do extract potash, which is used to grow the food that we eat. We use diesel-powered equipment to create these tunnels and extract the ore. Petrol or gas-powered vehicles are too dangerous in this confined environment, so it's diesel that we use. It's become clear over the past couple of decades that breathing diesel fumes is bad for human health. Cancer clusters and clusters of other illnesses are found around the world near congested roadways and ports where a lot of diesel particulate matter is produced. I'll bet all of you shut your car windows when you're driving through a tunnel in your city because you notice increased concentrations of exhaust gases. In a mine, it's not that easy. We're often working without the benefit of enclosed cabins. The exposure of our miners to DPM is excessive compared to the normal population, and it needs to be fixed. That's the primary health piece of the puzzle that we're working on. To help you understand where the direct economic benefit is, mines are regulated to pump a certain volume of air through the mine every second based on the total combined kilowatts of diesel power being used in the mine. So if you think about blowing air through a straw, you start blowing and a little bit comes out. You blow a bit harder, more comes out. But you get to a point where your eyes are popping out of your head and your cheeks are stretched and you just can't blow any more air through the straw. That happens in underground mines and we call it ventilation constraint. In this case, for every extra cubic metre of air that we try to push through, our power costs skyrocket. Most mines in Australia operate under ventilation constrained conditions. And at this condition, if you wanted to add one extra V8 Toyota Land Cruiser into the mine, it'll cost you an extra 100 or 120 grand a year just in electricity costs to move the extra air required. And the same is true in reverse. If we replace one Toyota with an electric vehicle, we can reduce our electricity costs by that magnitude. There are underground mines in Australia that have up to 250 Toyotas running around their tunnels, but the average is about 25 per mine. If you only get the benefit of reducing air volume, the average mine can save around $3 million a year on electricity by swapping out their diesel light vehicles with electric ones. But it doesn't end there. Many of our mines are deep and quite humid due to water ingress, and they can be operating at the working face with wet bulb temperatures above 30 degrees. For those of you who haven't experienced 30 degrees wet bulb, I can tell you it is far less pleasant than 45 degrees dry bulb. When you add to that the requirement to wear overalls, gumboots, a hard hat, cooling the human body can become very difficult. In these mines, we have gigantic air conditioning units, which cool the air going into the mine to try to keep us below this magical 32 degrees wet bulb limit where people start falling over. Electric vehicles are great because they produce 90 to 95% less heat than a diesel equivalent during operation. Typically, light vehicles account for 20 or 30% of the heat load in a mine. And if you were to turn these air conditioners off, you could have the same or even higher cost benefits again than what we've already mentioned. EVs also don't add to the humidity of the environment, unlike the diesel burners. So all of us tech heads have been using the excuse of reduced maintenance and operating costs for our economic reasons to change to EV. I hope you can see from my little Mining 101 short course that the benefits in mining far exceed just maintenance and operating costs. Because of my background in mining, when Tesla launched the Roadster, it was obvious to me that if it can work on road, it can work far better underground. I spent years watching and waiting for the OEMs to do something about it, searching to try to find someone who was doing something good and we could help them to get traction in Australia. But nothing good was forthcoming. You see, the business model for OEMs of mining equipment is to sell a piece of equipment at a competitive price and then reap the benefits of an excessively lucrative parts and servicing tail. Electric vehicles simply don't have the servicing or parts requirement that diesel vehicles do. So implementing this change was always going to be bad for incumbent business models. Mining companies, on the other hand, who are the ones who actually receive the benefits of this EV technology underground, they don't invest in product innovation. Their R&D budgets are around drilling to find new ore bodies. And they have a reasonable expectation that OEMs will do the development work for them. And this is why there is a commercial opportunity for small businesses like Safescape to push into a market that traditionally would have seen us stomped on quickly. Light vehicles in Australia are mostly Toyota Land Cruisers with some purpose-built tank-like machines. The Land Cruisers are used because they're the only on-road vehicle that lasts any reasonable time in this environment. They're actually quite good. And they cost around 100 grand to purchase and fit out for underground. And then there are these other things, we'll call them tanks, and they're much heavier light vehicles. And they're up around the $200,000 to $300,000 mark. They're not on-road vehicles. The average underground light vehicle will last 3 years, and in many mines will consume approximately $200,000 worth of parts during that time. I understand that this sounds ludicrous to the non-miners on the call, but it's true. Underground mines are a hideous environment for road-going vehicles. The air is dirty and wet. The road you're travelling on is unsealed and at a 1 in 7 gradient for most of it. You're in four-wheel drive low range all the time, and because no one can see you and you've got an important job to do, you'll drive that vehicle with your foot flat to the floor the whole time. On top of that, most mines are wet with hypersaline water. Forget seawater. This water is so heavy with salt, if you tried swimming in it, it's hard to stay upright because you float right up to your nipples. Often the water is also acidic. I've seen water that could eat through 3mm thick sheet steel within 24 hours. So it got to a point in 2018 when we decided that we would make an EV light vehicle for mining because we couldn't see anyone else doing it. And at that point, we didn't even consider using any of the vehicles currently used underground because we knew that the EV technology we were going to put into the vehicle would outlast 3 of the donor bodies, and this would be inefficient. So we searched the globe to find a vehicle that would last. We found it in the Agrale Mahua. This vehicle is a purpose-built military vehicle. It is incredibly heavy duty. Everything is over-engineered. Its body is completely galvanized and the chassis sealed. Unlike other road vehicles where the holes in the chassis allow them to rust from the inside out. It's made in Brazil by Agrale, who also make trucks, buses and tractors. It's built on a traditional production line, but it's built to order, which was very important to us. It means we can make changes to the design of the vehicle so that it has mounting points to suit our batteries, motor, etc. And we don't have to remove components when we get the body into Australia. So to be clear, we are not retrofitting. This is a ground up build of an EV that uses the bones of an existing diesel platform. Now, we've already homologated the diesel version of this vehicle in Australia. So we understand the process of homologation and we're confident that we can do the same for the Bortana EV. When we build these Bortanas, they will have our VIN number stamped on them and they will be available for on-road in both NV1 and NV2 classification. Initially, we'll have single cab and dual cab options, and it's likely we'll also progress to a minibus option as well. We've built our prototype and tested it over the past year, including a total of about 6 months on mine sites around the country. It's been received extremely well. In December last year, we began ordering components to support production at a rate of 1 vehicle per week, starting in July this year. Unfortunately, this COVID situation has impacted our timeframe, and it's still unclear when we will get our first production vehicles complete. But we're still hoping for this to happen in 2020. You might think starting a vehicle manufacturing business in the year of the virus sounds like a bit of a start to a hard luck story. But to put it in perspective, we started Safescape in the heart of the GFC. And by the time we actually got around to having a saleable product, my wife and I also had a baby. So there was a year there where our daughter was the biggest breadwinner in the family, bringing home the baby bonus. So, but with EVs, the fundamentals are still good for us. So long as our supply chain can make it through this period, we think we're still in with a shot. Now, I know most of your audience is going to be more interested in the tech side of the story than the commercial or the application side, but I feel it's important to understand some of the decisions that we've made. Like, you need to have some understanding of why we do what we do and the market that we're working in. So I hope you can appreciate the reasons for choosing such a ridiculously tough platform. And yes, it is heavy. Our prototype weighs 3.7 tonne before you add the electrons. And we expect to get the production vehicle down to about 3.5 tonnes, but considering the GVM is 5.7 tonnes, we still have a usable payload. When we looked at batteries, we wanted lowest total life cycle cost, which we thought meant it would be made up of high quality NMC pouch cells, extremely robust, extremely safe, and maintainable. You're probably thinking we're asking too much. There isn't anything on the market that meets all of those criteria, and at the time you would have been right. Our partners at 3ME Technology in Newcastle have designed a battery that meets all of these input requirements, and only time will tell whether we achieve the overarching goal of lowest total life cycle cost. To be clear on that, our batteries are not cheap, but they are good value. On the vehicle, we have two packs, one which sits under the bonnet and another which will sit underneath the tray. They're each 25 kilowatt hours, so a total of 50. They're connected in parallel and provide nominal 350 volts. Our drivetrain consists of the original differentials from the diesel version and a slightly modified transfer case that provides us with two options for motor to drive shaft ratios, being 2.7 to 1 and 5.4 to 1. We have a single drive motor mounted directly to the transfer case, which can rev up to 10,000 RPM and provides a very flat torque profile with up to 350 Newton meters and a peak power of 160 kilowatts. What this means for us is in high range, we have a vehicle that accelerates comfortably in traffic and gets up to highway speeds, but in low range, we have a very impressive performance, both in terms of acceleration with a load up a hill, but also for regen when descending a steep hill with a load. As a four-wheel drive, the performance is outstanding. People often don't realise that they're not breaking traction because of particularly loose terrain. They're breaking traction because their engine has to retain revolutions to deliver torque. So it's a trade-off that results in losing traction on one or more wheels. Driving the Bortana up a steep gravel hill at low speed where a diesel equivalent will break traction, you can come to a complete stop and start again without spinning a wheel. And at the same time, you can hear the birds chirping outside while you do it. We use a 350 volt hydraulic pump to support steering, which makes low speed full lock direction changes comfortable. We had wanted to use an electric brake booster. Unfortunately, the companies who provide them don't get out of bed for less than 30 units a day, and they don't allow you to use an existing part that they already make for another vehicle. Instead, they like to charge you $1 million to do a risk assessment and have a few Zoom meetings before selling you an existing part with a modified mounting bracket. So we also run an electric vacuum pump to support the vacuum brake booster. Charging gets interesting for our market. In Australian underground mines, we reticulate 1000 volt AC power. There are power points distributed throughout the mine. There's one on a wall pretty much wherever you might think to park, and they can supply anything up to 200 kilowatts. Unfortunately, when we started, there was no such thing as an onboard charger that receives 1000 volt AC, because in Europe and North America, 1000 volts is quite rare. There are no 415 volt outlets in underground mines, nor are there yet any high-speed off-board chargers. So to get started, we needed 1000 volt on board. 3ME led this project and chose a particularly capable manufacturer in Europe to build us a charger. It was not cheap, but unlike the electric brake booster, this wasn't an option for us. We had to have it. When we're charging the vehicle underground, near to where the driver is out working, we don't want them to have to walk back to the vehicle to check state of charge. We needed a system on the vehicle that would report state of charge at a reasonable distance. An RGB strip was programmed to show the state of charge in increments of 33%. It begins with red, then orange, then yellow. Finally, when fully charged, turns green. And this is great if you're not colorblind. But for people like me, we added in an extra feature for when it's fully charged. So if like me, you were a kid in the 80s, you no doubt get this pop culture reference. But for those in the audience who are younger and wondering why there's music verging on the pornographic, this is the theme song to a show called Night Rider. You should check it out.
I think you probably find there's quite a few people tuning out and going to find out what Night Rider is all about now. I reckon there's a fair few people on the call who would love to have that feature on their cars as well, because I know, obviously, from my perspective as well, it's always nice to know what your car's doing from 100 paces, and that's absolutely perfect.
Yeah, it's going to be really valuable for our application. We don't want to walk them back to check out their study.
No, absolutely. I think also, just coming back to one of your early points around OEMs and their business models and all of that kind of thing, I think what's particularly interesting in terms of the reasons why you've developed this, the Bortana, and also why there's a requirement for it. I think a lot of what you talked about actually leads into regular driving on the surface, I guess. Really, it's just that it's been accelerated because of obviously financial reasons in terms of the pushing the air into the mines, I guess.
Yeah.
So you would. Yeah, so that's obviously that's a requirement now, and obviously there's a business case and all of that kind of stuff. But at the same time, you can imagine the sell would be just as easy on the surface in a few years' time, for sure.
Oh, good. I'll keep going.
Yeah.
Yep. Right. So back to the importance of the 1,000-volt charging. You see, some mines in Australia are up to 2,000 metres deep. And if we started on the surface and drove to the bottom of the mine, we'd have to start with less than 70% state of charge because of the amount of regen that you get from going this deep. There would be an extreme element of range anxiety if we couldn't charge underground. Sure, we could have asked our customers to install off-board chargers at strategic locations throughout their mines. But the cost of this is not just the capital, but also the time wasted waiting to charge a vehicle at a location where you can't be doing work. By using the existing infrastructure, workers don't have to stop to charge their vehicle. Instead, they charge while they are stopped for work reasons. With the aircon and heater on the prototype, we installed a high voltage aircon unit, installed a CAN node to the back of the existing analog control panel, and programmed it to work from the original controls. For production vehicles, we had the option of either installing a HMI and programming air controls into it, or installing some simple CAN switches. If we felt we needed a HMI for the production vehicles, we would have done this, but we think we can get away without using a HMI. So instead, we'll use CAN switches.
Sorry, HMI?
Human machine interface, like the touchscreen.
Yeah, okay. Yeah. And we've also got just to interject there before you get onto obviously charging and all that kind of stuff. What is your expected range and runtime?
Well, I'll get to that.
Okay, sure.
That's all right. We'll just put it in context with the rest of the information around it.
Yeah.
Cool. Yeah, so we'll use those CAN switches for items such as the aircon, and then present all of the other relevant information onto a digital cluster display that's programmed to suit our application. At low speeds and on sealed roads, the Bortana is pretty quiet, as you'd expect. Currently, there's no requirement for on-road to have a noise emitter, but we're going to put one on there because it's a question we often get asked by customers, and we believe that sooner or later it will become a requirement of on-road vehicles as well. And the way it works is from 0 to 20 kilometres an hour, a sound is emitted at a certain decibel that raises in frequency the faster you go. So you can hear whether a vehicle is speeding up or slowing down without looking at it. From a software standpoint, our drive program is put together by 3ME. They have a very switched on team with extensive experience in this field. There are a number of features that we could talk about, but to give one example, consider the gear change from forward to reverse and back. I can't talk to any other EVs on road, but with a Tesla, you can select the opposite gear while you're rolling up to a certain speed. But beyond that speed, if you attempt to select it, the car beeps at you and it stays in the original mode. And this is quite handy when you're driving along the freeway and you go to put your indicator on to change lanes and forget that you're driving a Tesla. But try to imagine what it would be like for us underground. We're regularly doing 3-point turns inside tunnels that are typically 5 metres wide. So you'll turn into a T-junction tunnel while you're slowing down and select reverse while your foot's still on the accelerator pedal. Push harder on the accelerator pedal to control region and then start reversing. This is such a beautiful sensation once you get used to it. Instead of requiring 2 hands on the steering wheel, 1 on the gear stick, a foot on the clutch, a foot on the accelerator and 1 on the brake, waiting for the gears to mesh and all that, it's a single pedal process. And because of the electric steering pump, you've got max power steering at low revs, it's as smooth as silk. But imagine if one day you're going into it a bit too confident, like I'm sure all Tesla owners have, and you think you're going slow enough, but you're not. Hopefully for all of us that's happened to, we've had enough room in front of us to stop before hitting a rock wall. But in the underground situation, you really don't have any room for mistakes. So for us, if you change, for our vehicle, if you change from forward to reverse, the car changes from forward to reverse, just like you want it to. If this happens accidentally, when you're meaning to be traveling at 30 kilometers an hour and someone's following behind you, they'll see your brake lights come on and your reverse lights come on, but the car won't instantly stop. There's programming in there to limit the amount of regen torque that you can use during the transition from forward to reverse, meaning you slow down at about the same rate you would if you took your foot off the accelerator. So you're probably thinking to yourselves, heavy car, small battery, shaped like 2 house bricks glued together, what's the range? At highway speed, it's around 100 kilometers an hour. In city traffic, we get about 160 k's. So if you're one of those people that fit into the category of environmentalist / four-wheel drive enthusiast / tech head / cashed up bogan, you're probably picking your smile up off the floor. This vehicle will be fantastic for off-roading, but it's going to be hard to get it to where you want to get to first to do the off-roading. But fear not, it is in our roadmap to develop a suitable range extender module for applications that require significant range. For the underground application, our customers are interested in how many times it can drive up and down a 1,000 metre deep mine. And we've proven that's about 4 cycles. For most applications, it lasts a full shift comfortably, but there are ample charging opportunities through that shift to ensure it's ready to go for the next shift. We will also offer an option for double the battery capacity for customers that do not have the distributed charging infrastructure, such as large open pit mining operations, fire and emergency services, and conservation and land management. So, sorry for not answering your question earlier, Russ, but I had it all teed up.
No, all good. All good.
And that's my presentation. So over to the question.
Excellent. So I guess one of the questions here is around ADR compliance. I knew this was going to come up, and so did you. So did you, I guess. Where are you at in terms of ADR compliance for the Bortana for it to be on the road?
So the prototype is on the road under engineering and evaluation. It's not been it's not been through the homologation process. Yeah. The production will go through the homologation process and therefore be defined as being ADR compliant. Yeah, okay, but I presume it's not necessarily needed for operation on the mines underground. No, it's not, but it's handy. Yeah, of course. Yeah, it means you can use it in more than one place, obviously. Yeah. And does it have ABS and traction control and all of that kind of stuff as well? It has ABS and it has what's the other one? What do you call it? Stability control and all that kind of stuff. Yeah. Yep. But it doesn't have traction control for acceleration as such. Yeah. That's what. Yeah. For sure. And in terms of the battery itself, what's the chemistry that you're using for it at the moment? It's nickel, manganese, cobalt. Okay, so I think that's the same as what's in the Nissan Leaf, I think, from memory. Okay, I'm not 100% sure. Yeah.
It's it's an incredible looking vehicle, and obviously reminiscent of the Hummer as well. I'm guessing a fair few people confuse it for being one of those as well.
Yes, yeah, a lot of people do think they've seen a Hummer driving along the road, but it's
Yeah.
not. It was actually designed to replace the Brazilian military's Hummer fleet, and Agrale was given the mandate to design something which was lighter, carried a higher payload, doesn't rust, cost less to maintain.
Yeah,
blah, blah,
yeah,
blah.
and I think the point I'd rather clumsily try to make earlier was that the whole maintenance thing is obviously huge. It's compounded right across the board, isn't it, in terms of the maintenance cost for a conventional Toyota Hilux, which is meant to be, you know, the hard worker of Australia. Doesn't last any time at all underneath 3. I mean, with the photos that you showed earlier, where it's all rusted and up and obviously incredibly degraded, it's just incredible. So obviously, the maintenance costs associated with keeping those things on the road is just obviously it squares, or it increases the desirability of such a machine, I guess.
Yeah.
What about charging itself? So how long does it take to charge from flat, and how many k's per hour are you actually putting into the vehicle when you connect it to 1,000 volts?
So it's running at 25 kilowatts, and we've got a 50 kilowatt hour pack, so about 2 hours from empty to full.
Okay, cool. And so that's AC on board, is it? Is that what you're using?
Yeah, we're taking the AC on board.
Yeah, and I think and are you looking to do DC fast charging?
Yeah, yeah, our cells are all rated to 4C, so we'll be able to charge reasonably rapidly off a off-board DC charger.
Yeah. Okay. Cool. And we've got another question here from Stephen Harrison. Excluding mine ventilation costs, what's the full life cycle cost compared to a diesel Toyota?
So we haven't had it underground long enough to know. We've only had it underground for just under 6 months.
Yeah.
So it's cost nothing in that time, but that doesn't mean anything. We're not going to know for probably 10 years, 8 to 10 years. This vehicle will outlast a traditional vehicle by a country mile, and we won't know the full life cycle cost, because capital cost matters, operating cost and maintenance and time out matters.
Yeah. And
that capital cost piece is really defined by how long it lasts for. So a Land Cruiser will last between 1 and 3 years underground. And there are outliers that keep them maintained for 5 or 6 years, and some sites that don't have very corrosive water, but that's the average. And so
it's lasting 3 years with a whole lot of maintenance across the board, though, while it's down there as well, though.
Yeah, exactly. So we'd be expecting lower total cost of ownership than a Land Cruiser.
Yeah, for sure.
In any role in a mine, but not on a farm, right? Like if it's on a farm, a Land Cruiser is going to probably beat us there because they don't consume as many parts there. But on a mine, we should beat them on total cost of ownership.
Yeah, look, like I said, I think what's interesting with this is that the total cost of, obviously, electric cars at the moment, they're considered to be expensive, borderline luxury item, depending on the brand that you go with, obviously. But the total cost of ownership, which is actually an IT term, I think IT guys will probably lay claim to that acronym. But total cost of ownership is often overlooked, and I think the accelerated wear and tear and the maintenance on these vehicles, the Toyota Hilux is just obviously it compounds the business case, obviously, for such a vehicle. And I think those kind of sums could easily be applied to surface vehicles as well. One other thing is, how did the partnership with 3ME come about? That's pretty interesting partnership you got there as well?
Actually, I was introduced to 3ME before we made the decision to build an EV. And it was actually what they were capable of through seeing some of the other work that they'd done, that led us to think, hang on, we can have a play with this. Yeah.
And did you have any experience with electric motors and drivetrains and all that kind of thing previous to this, or have you had to learn essentially on, internal, teach yourself as you've gone through it?
Mainly, my personal experience was mainly behind the steering wheel of an electric car.
Yep.
I'm a mining engineer. I'm not an electrical engineer or electronic engineer. I'm not full ball on that stuff. But it's more about the application side for me and how much value can be generated on the application side.
Yeah, I think what's interesting, there's been lots of talk with COVID-19, etc., about businesses, pivoting, which is actually a slightly overused word. For example, one of our customers or partners has turned from manufacturing renewable equipment to face masks in the last kind of 4 weeks. But it seems that you pivoted way before COVID in terms, from what you were doing previously, and getting into a vehicle. It's as far away from what you were doing previously as you can imagine. So yeah, it's really impressive how you managed to bring that around. What's the plan for the range extender? Is that, how far down the road is that in terms of development?
It's just an X in a box on the end of the line at the moment. We will do it.
It's a new Trello board somewhere, is it?
So the way that we typically try to do things is the old minimum viable product process, to get it out, test it, fix it.
Yeah.
And so we will do that because we know that there's value out there for it. I mean, even just for me, I'm going to want to drive one of these around, and I'm going to want to drive at a distance. So I'm going to want one. So we'll do it.
I'd love to see how long an Outlander PHEV would last underground as well. That'd be pretty funny. Which is basically what you'll be end up creating. It'll be a plug-in hybrid of some description then, won't it? Really? You'll be plugging in, and then also you'll be having an engine on the back as a range extender, I guess, too.
Yeah, but it wouldn't be ideal to do that underground. The value in using it underground is that it's full EV.
Yep. Yeah. No, I understand. Yeah. In terms of the battery pack itself, have you got cooling or heating as part of that? Is that something you need to do?
Yes, absolutely. It's having control. So there's a few questions on there about the battery, and so I talked about being critical that it's very robust and very, very safe. And when you look at 3ME's battery, you see that the levels of safety through monitoring and through packaging and design are just far higher than anybody else's that we were able to access. Yeah. So this design is incredibly safe. And yes, you could have a situation where it could catch fire, but that situation is in a situation where you've just had a 100-ton rock drop on it. It's not a situation where a rock hits it, a basketball-sized rock hits it, or a bolt hits it, or something like that. It's a very, very safe unit, and that was very important to us because lithium-ion battery fires, like we all know that they occur with the Samsungs and the skateboards and whatever else, and sooner or later, an electric vehicle will catch fire underground due to some reason. There's lots of reasons that could cause it, but sooner or later that will happen. And if that happens in the first 2 or 3 years that EVs are being used in underground, it's going to cause huge problems. And we needed to make sure that it wasn't ours that happens to. So when that happens, if and when that happens, it won't be our vehicle that happens to. And if they stop all other vehicles from going underground, they won't be stopping ours, because we'll be able to show why it's not going to happen. Yeah.
There's a couple of questions from Mr. Attendee, first name anonymous.
Yeah.
Have you see that? So what makes this vehicle more corrosion resistant than a mine spec LC70 I think you covered this off, but it's what do you call it? What's the word? You can take that. Sorry, there's it's coated chassis. Is that right?
Yeah. So the chassis is sealed. It's also, there's a lot more steel there. There's actually a lot of iron there, and the chassis is sealed. So typically a Land Cruiser chassis has lots of holes in it from manufacture, and the salt water and the mud gets in there and you can't get it out, and it's always in a humid, hot environment, and it just corrodes from the inside out. You know, these things snap in half after 3 years, and you can't sell it. Like, there's nothing left. It's just scrap.
Yeah, quite clearly.
Our vehicle is so sealed chassis.
Yeah.
And
galvanized, I presume.
Yeah. No, the chassis is not. It's painted with a special paint with extra protection, but the body is galvanized. Right. So every paint.
Yeah. Okay. Interesting. And I guess from a weight perspective, because these vehicles were, I guess, originally designed to be petrol or diesel. So what's the weight difference between the two versions? Is there much of a difference?
Yeah, it's plus about half a ton at the moment.
Okay. Yeah. No, that's fascinating.
Which is a lot. And so the other question there is from Tim Harrison is what do I think about the competition regarding mining vehicles being converted? So I think it's bloody great. Before, what I said, the value that is generated in the industry by doing it from a safety standpoint and from a ventilation standpoint is enormous. And it doesn't matter whether it's ours or somebody else's, that value is still there. And that's really important. We didn't choose those vehicles to convert because they're not going to last long enough. So where others have chosen a particular, there's lots of ways you can go, and others have chosen an approach where you go for the low capex approach, and we have not gone the low capex approach. We've gone the low total cost of ownership approach, which is harder to start with, but in the end is what underground mining needs. If you look at the type of vehicles that have lasted the distance and are popular now, they're the ones that are almost unbreakable, and that's the approach we've taken.
Well, I think it's a great example for fleet owners on the surface as well, like to look at the TCO rather than just the sticker price, which is always a thing, right? When you know the maintenance and the robustness. If you've got a vehicle that costs a bit more, or a lot more, or whatever it's going to be, then but it's going to last 10 years, which is seemingly, I think, is your expectation. Is that right? You're not. Yeah, it's not. 3 years would be pretty poor investment for any. It is for obviously the mining sector, because that's what they're getting out of the Hilux. That sounds terrible. And like you said, after 3 years, it's not a case of sending it to pickles and getting, maybe 60% of your value back. After 3 years, they're basically finished, and no one wants them, right? So you're obviously extending the opportunity or the investment way beyond that 3 years, and 8 to 10 years, or whatever it's going to be. So that's got to help, I guess, fleet owner, not only fleet owners actually, but also private owners understand that they can buy an electric vehicle. It will cost you more upfront, but taking this as an example, you're going to get a much better value out of the vehicle, as long as you're happy with it, in terms of shape and functionality and how it drives and all of those kind of things.
If you look at this thing though, like that, I agree with what you're saying within reason, because this is a bit like a Kelvinator fridge. If you remember the old Kelvinator fridges, there's still one in the shed. They still work now, even though they're 50 years old, but they're not efficient anymore. And so the approach that others have taken with, like I say, the low capex thing, they're saying to themselves, well, there's no point investing in something which is awesome, because 3 years' time we're going to have fancy chemistry that you can paint on the batteries onto the car, and you don't need to do anything, and it charges from clicking the steering wheel or something. And that's what they're thinking, and fair enough, that's an approach. So for us, This car has to be able to last 10 years in a mining environment, and that's extreme. And most people don't believe that that's possible, but we're confident. And but in reality, you don't need it to last longer than that, because by the time we get to 2030, so much is going to be different that it's not going to be efficient anymore. It'll actually have a higher total cost of ownership in that moment. So there's a limit to how far you can go.
Yeah. No, absolutely. Look, new technology after 10 years, it'll be, obviously, hopefully be far superior, but I think there's still opportunity for this chassis to be extended as well beyond that, I think is my view as well. Not that I know anything about these vehicles, obviously, but that's a personal opinion. Another question from Tesla Tom. How you going, fella? Do you see that question if you scroll up? It says, you mentioned 4 cycles per full charge. Is that enough to get through the entire day, or does it need a recharge part way through?
Yep. So Tom, there are different applications for light vehicles in mines, and in some applications it is enough in a deep mine, and in some applications it's not enough, where they're actually driving up and down with a load most of the day. But there's always time in their shift where they're stopped, whether that's to unload something or to do a particular task in that area, whether they're a pump fitter or a spark or a shift boss. And of course they stop to eat at some point. So there's always that chance to charge when they stop to eat.
And how many charging stations are there? In typically, I know it almost sounds like a stupid question, but I mean, where you're currently testing the vehicle, and how many charging stations are there?
Heaps. So everywhere there's an active heading, there are what we call jumbo boxes. Everywhere there's a pump box. Everywhere, so there's fans which are using electricity to move area. There's electrical infrastructure everywhere, and you might only have to, the longest you might have to go might be a kilometre to get from one to another.
Yeah, so you're making everyone on the surface jealous now, obviously, because we don't have that currently in
there's no
anywhere else.
Yeah.
Okay, that's amazing. And I guess there's another question there from Hannah. I think we've covered these off, but I'm not sure now either. Are these actually commercially available and I know you've got one in one prototype in use at the moment, but are these commercially available now? Could someone actually go and add to cart and check out and buy one of these off you?
No, they can talk to us about preparations. We're planning to start, as I said, that we started ordering the components, the long lead components, in December last year, and we were expecting to start production in July. COVID impacted that because many of our supply chain companies are currently shut down. And we don't know when they will restart. So we're still hopeful of being in production this year, but we just don't know.
So you're actually going to manufacture in Geelong? Is that the plan?
Bendigo.
That's great. That's so good. Yeah. And in terms of the facility, how many do you think you can make in a year, or in a week, or a month? That kind of thing.
Well, that's the challenge, Russ. Is we don't expect it to take very long to build them, because the hard work is being done elsewhere. So the body is being built, body and chassis is being built in Brazil, which is that takes a long time and requires a lot of spanners. And then the batteries are being built by a whole host of other, the components are coming from a whole host of other companies, being built by 3ME and being given to us in kit form. So our actual manufacturing is not going to take very long. So we're talking about starting at 1 vehicle a week, but we would expect our capacity to be able to get up to 50 vehicles a month within 12 months. That's realistically achievable from a technical standpoint and from a supply chain standpoint. The only thing that's hard about that is the capital required. Because, you've got a 6-7 month lead time from the first components that you start ordering to delivery, and you've got 50 a month. That's just enormous. And so that is going to be our challenge.
Do you think there's a market for tradies for these things? Can I expect one of our installers to start rocking up in one of these in a couple of years' time?
I think you should. I think that's something that you should be aiming towards. I'd be supportive of that.
Yeah, I'm sure you would be, but I guess, do you think there's a market there? Is that something you're preparing for in terms of, not just, obviously previously a military vehicle, as was the Hummer, and before long we saw the Hummer being, used by movie stars and all this kind of stuff, and then eventually Sparkies. So, do you think is that something you're going to target, or you're going to aim for?
That's not where we're targeting. We're definitely targeting at the industrial end because of the higher capex. So if you think of most electric vehicles that are replacing a similar sort of ICE vehicle, they typically 2 to 3 times the price. If it's the same sort of spec, that's what you're looking at, 2 to 3 times the price. And these diesel vehicles are depending on spec, in the 130 to 150 range. They're not cheap. So it gives you an idea about what the end cost is going to be. It's not really going to be your typical plumber that's going to be using.
Yeah, it depends how much the plumber charges, obviously, because
lawyers could be doing it, no problem at all, I'm sure.
Yeah, the latest plumber I had was pretty expensive. So yeah. So I guess the other one, I've got a question from Nicholas Gardner there. Can it tow? I presume it can, but
yeah, it can.
Yeah. And what's the tow range? Like 10.5, that kind of thing, or can it go more?
We'll be looking at. It'll be the highest you can legally tow, basically.
Yeah. Okay. Yeah. Yeah.
Braked with a 50 mil tow ball.
Yeah. Okay. Cool. And obviously, you've taken these vehicles and converted them here in Australia and eventually in Bendigo, which is just awesome for local manufacturing. I think it's something everyone wants and is supportive of. There's no doubt about it. So hats off for you to doing that. Do you think there's a chance that you'll be able to export these back to Brazil or overseas? Because we're not the only country that does mining, right, as well.
Yeah, for sure. We get probably more interest from overseas than we get from Australia at the moment. So we're very high likelihood that we'll be sending them overseas. And whether we build the left-hand drive version of the vehicle here or do it in Brazil is still up for debate, because it doesn't make sense to import it and then export it again. So we'll be working on that with our friends in Brazil. Yeah.
Okay. No, that's great. I think obviously we're just a small market ultimately with these, small population compared to the rest of the world. Sorry. So, if you've got a unique proposition, obviously I don't need to tell you there's probably a good opportunity overseas as well. Yeah. So I'm just trying to think. So military. Stephen Moore's asking if there's a military application for it. Obviously the diesel version there is, but is there an opportunity for the electric version to be military spec at all?
Yeah, I expect that there probably is an application there, and we'll be working with our friends at 3ME to try to develop that. They're closer to the defence industries than we are, because we're typically mining. But yeah, I do think.
Okay. Yeah, excellent. I think that's it for questions, Steve. So that's been absolutely fascinating. It's great to see such a unique vehicle being manufactured locally, and yeah, best of luck for the future with that. And yeah, look, like I said earlier right at the beginning, the live stream is being recorded, and we'll upload that tomorrow morning up to our YouTube channel, so you'll be able to watch at your leisure. If you've got any additional questions, obviously just reach out to either myself or to Steve via the links, and via the various social methods, etc. And yeah, and we'll do all our best to answer that. But thanks again, Steve, for your presentation. It's been great. and yeah, incredibly fascinating and educational at the same time.
Awesome, thanks. And yeah, just thanks very much for the opportunity, and just reiterating, if there are any questions that we missed, or if there are questions that you want to ask,
yeah,
probably the easiest way is to find me on LinkedIn.
Yeah,
just
absolutely. All right, cheers guys, and thanks again for all the great questions. That's been great. That makes it for sure.
Awesome.
Thanks guys.
Cheers.
All the best. Bye.